Our final example, number 16, we have dy dx is equal to 4x times the quantity y plus 2 being cubed, and our initial condition is that f of 0 is equal to a half. All right, so we're getting to be old pros at this, and I would certainly encourage you to try as much of this as possible on your own. You can pause the video as need be, but let's go ahead and see what the solution is for this differential equation. We're going to divide both sides by y plus 3 to the third power. So we have dy over y plus 2 cubed, and that's going to be equal to 4x dx. Okay, that's how we can separate our variables. That's basically the only way that we can separate our variables. All right, so we're going to anti-derive both sides. And this y plus 2 cubed, again, this is not going to be a natural log problem. This is going to go back to example number 11, I believe, where we have an exponent other than 1, which means we have to think of it like a negative exponent. All right, so we have to think of this almost as y plus 2 to the negative 3 power dy if we were to move it up into the numerator. Okay, so this becomes y plus 2 to the negative 2 over negative 2 when we anti-derive it. And the other side will be 2x squared. And as always, we need r plus c. Okay. And we're going to use our initial condition to solve for c. So we're going to plug in 0 for x, meaning that we just have c over here because 0 plus c will give us c. And on the other side, we have to plug in a half for y. So we're going to have 2.5 to the negative 2. So how about if we turn this, actually I guess let's base over here, yes I do. So I'm going to make this 1 over negative 2, and then we have y plus 2 squared. All right, so that's 1 over negative 2, and then we're going to plug in a half for y. So that's 2.5. 2.5 is the same thing as 5 halves, so we have 5 halves being squared. Okay, that's what our value of c is. And you can use that because you don't have to simplify. I'm going to neaten it up just a little bit, but again, you don't have to. Just keep that in mind if we're in the open response section of the exam. Okay, 5 halves squared is really 25 over 4. And we're going to multiply that by negative 2. So negative 2 knocks this down to a 2 right here. So we have negative 25 over 2 in the denominator. So we have 1 divided by negative 25 over 2. So we're divided by a fraction, which means we multiply by the reciprocal. So this is our c, which is also the same thing as negative 2 over 25 if we reciprocate that. So we got a little bit of arithmetic that we have to deal with for our simplification purposes. But now that we see that c is negative 2 over 25, we have, going back here, we have 1 over negative 2 times y plus 2 squared equals 2x squared minus, where am I? Oh, sorry, right here, minus 2 over 25. Oops, that's not a 25. There we go. All right, we got to get y all by itself. All right, so what do we got to do? Well, for starters, we got to multiply by negative 2. That'll wipe those out. We multiply by negative 2 over here as well. All right, that means that we now have 1 over y plus 2 squared is equal to negative 4x squared plus 4 over 25. All right, you can see that we're going to have to reciprocate this so that we can have y plus 2 being squared. And that means we have to reciprocate this as well. So it might make sense actually to turn this into just a single fraction. If we put this over 25, let's see, we want 4 as our coefficient. So 4 is 100 divided by 25. So this is the same thing as negative 100x squared over 25 plus 4 over 25. And again, I can combine my two fractions now that there's a common denominator. So I have negative 100x squared plus 4 over 25. Or we can flip the numerators. We have 4 minus 100x squared. We're just going to alternate that so it looks a little bit nicer. All right, so we have 4 minus 100x squared over 25 is the same thing as this. So when we flip it, it becomes a lot nicer and easier to do. It's 25 over 4 minus 100x squared. Okay, now we take our square root. So we have y plus 2 is equal to the square root of this. And keep in mind, because we took a square root, what do we need out front? That's right, we need the plus or minus. And then we have to subtract 2. So we have y equals plus or minus square root 25 over 4 minus 100x squared, and then outside of the radical there's a minus 2. Okay, so which one is it, plus or minus? Well, we go back to the initial condition. When we plug in 0, we need to get a half. So if we plug in 0 for x, then we have 25 over 4. All right, the square root of that. The square root of 25 over 4, square root of 25 is 5, square root of 4 is 2, so this becomes plus or minus 5 halves minus 2. All right, well, we want our answer to be a half, so 2.5 minus 2 is a half, which means we want the positive version of the radical, which means we can just totally eliminate the plus or minus, and we just have square root of 25 over 4 minus 100 x squared minus 2. That's our answer.